One of the types of equations that we're covering in this section of other types of equations is rational equations. Now, equations are named by where the variable is. So rational is just a fancy word for fractions. So what we're looking for is a variable in the denominator here, and that's what makes it with that fraction, and that's what we see right there. So if I'm going to solve this, just like we solved our linear, we want to eliminate the fractions. Now when you eliminate the fractions, you want to see what all of the denominators are. We have a 1, an x minus 1, and a 3. So those are all in the denominator. Now the other thing we want to look at is what can my answer not be? And we know the black hole happens when you have that 0 in the denominator. So if you look at these denominators, this first one with a 3, that 3 is not going to, there's nothing that is a variable in that. This x minus 1, however, that variable, tell me the value of x that it cannot be to make a 0. Does that make sense? So basically I want to say what value of x is going to put a 0 in the denominator when x is equal to 1, right? So if I'm looking at this, x cannot equal 1 because that's what's going to put a 0 in the denominator. Anything else is fair game, just that 1 is not going to work out. Cool, okay, so now we got to get a common denominator. So a common denominator for this problem means I have to represent anything in the denominator. So I have a 3, an x minus 1, and a 1. So if you represent this, I'm going to multiply this by a 3 times x minus 1, because this extra 1 doesn't, 1 times anything is itself. So basically what you're doing here is, okay, 3 is in common, so I cancel that out. I'm multiplying this first fraction by an x minus 1. The x minus 1 cancels out, and I'm multiplying that second fraction by a 3. There's nothing to cancel out here, so I'm going to keep that whole thing for that third one. So what we actually have is 3x minus 1 times x minus 1 for my first term, no more denominator, minus a 3 times that 2x equals 3, then times that x, and then times that x minus 1. The whole goal, again, just like with linear, is to get rid of the fractions. Once you get rid of those fractions, and then you can just do work. So let's do it right now. If I FOIL out these first two terms, we end up with a 3x squared minus 3x minus x plus 1. Multiply that together, and I get a negative 6x. Distribute that 3x, and we get a 3x squared minus 3x. So you want to combine your like terms on the left so that we can simplify this. So I get a 3x squared minus 10x plus 1 is equal to a 3x squared minus 3x. So anytime you have a squared term, you always want to try to get it by itself, but look at what's happening here. If I subtract a 3x squared from both sides to eliminate it, they're gone. So I really no longer have a quadratic at this point. So negative 10x plus 1 is now equal to that negative 3x. I'm going to add a 10x here just so that I can keep my variable coefficient positive. So 1 is now equal to 7x. When I divide both by 7, x is equal to a 1/7. Woohoo! Now, does that fit our criteria? You always, 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 when you have a rational expression, have to go back and make sure that whatever answer you come up with does not make your denominator 0. If it doesn't, in this case it does not, we're good to go. Woohoo! Let's do some more. So anytime you're looking at a rational problem, you always first want to look at this and say, what is going to make your denominator 0? It's the same for these, so I can look at this and say, okay, x cannot equal 2 because that's, if I have 2 minus 2, that's what would make it 0. So we know that's taken care of. Then you get your common denominator. Because you have the exact same thing, that makes it easy. So your common denominator is x minus 2, and that is what you're multiplying your problem by. So x minus 2 cancels out in the first one, I'm just left with x. X minus 2 cancels out in the second one, I'm just left with 2. And then there's nothing to cancel out in the third term, so I multiply that. 2 times my x minus 2. No more fractions, just do work. So x is equal to 2 plus a 2x minus 4. Combining those like terms. Sorry. And you just solve for x. So when we combine the 2 and the negative 4, I get 2x minus 2. I'm going to go ahead and subtract my 2x from both sides. So negative x is now equal to a negative 2. So x is a positive 2. Now, look at what just happened. I came up with the answer of x equals 2. Can I have that? No, because when you check this in the denominator, 2 minus 2 is equal to 0. Anytime you solve an equation, you are figuring out the value of x that makes the statement true. That is what you're solving. What value of x is going to make my statement true? Well, if it puts a 0 in the denominator, my answer to this one is a big fat no solution. There is nothing that I can plug in for x that's going to make my statement true. Make sure you're checking that denominator. That's the key to these problems. Cool. Let's do some more. Woohoo, check out this rational. I bet you're really excited. You know why? As soon as you see a square term, what do you know you get the opportunity to do? Factor. Whoop, whoop. So, as soon as you see something squared, and the first rule of factoring is GCF, taking out that greatest common factor. So in this instance, I can factor out an x, and that leaves me with an x minus 2. So now, again, you still look at all of your denominators, and you come up with what x cannot be. In this instance, because I have both an x and an x minus 2, x cannot equal 0 or 2. Either one of those are out. So because we have a quadratic here and we have multiple denominators that have an x in them, you have to account for all of that. Cool. Now, the process is the same. Find a common denominator and eliminate the fractions. So you know you got to represent. I'm representing this denominator, and when I represent that, I'm looking for x and an x minus 2. So the x minus 2 cancels out, and I just have an x times that 3x plus 2. The x cancels out, and I'm left with 1 times that x minus 2. The whole thing cancels out on the last term, and I'm just left with a negative 2. Then we simplify our left side here. So we've got a 3x squared plus 2x plus x minus 2 equals a negative 2. Combining your like terms, I have 3x squared plus a 3x minus 2 equals a negative 2. Now, as soon as you see that square term, woo, 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 lights are going off, sirens are happening. That means set it equal to 0. Because remember when we solved quadratics, you can set this equal to 0, and with that you can either use factoring or the quadratic formula. So that's what we want to go with. So let's do that right now. If I set this guy equal to 0, I'm going to add 2, because we want our leading coefficient, the squared term, to be positive, and check out what happens there. You're left with 3x squared plus 3x equals 0. All right, I no longer have a trinomial, but remember the first rule of factoring is greatest common factor, just like it was in our denominator. So what's our greatest common factor here? Yep, that's right, 3x. So we factor out that 3x, and now I'm left with x plus 1. Now, they both have an x term, so you take everything you've got and set those equal to 0. So 3x equals 0 and x plus 1 equals 0. When I divide the first one by 3, I get x equals 0. And subtracting 1, I get x equals a negative 1. Those are my two answers, right? Ah ha ha! Good for you. Way to pay attention. Notice this x equals 0 and this x cannot equal 0 because it's going to make my denominator undefined. Very cool, very cool. So with that in mind, my only answer to this problem is x equals negative 1. We cannot have x equals 0, makes the denominator out. Pretty sweet, right? Hey, let's do another one. We're on a roll now. Okay, the awesome part about this problem is that you get to factor first. With that squared in the denominator of this third fraction, we know we get to use the difference of squares. So let's factor that first to get us x plus 1 and x minus 1. And now we determine what x cannot equal. So if I look at all of the denominators, I know x cannot equal a positive 1 or a negative 1. So really what you're doing when you're looking at those denominators is you're saying, what can I plug in for x that's going to make this 0? For this first one, it'll be 1. 1 minus 1 equals 0. Here, negative 1 plus 1 equals 0. And because this is the same, two values, then we know we're good to go with positive and negative 1. Now, we get our common denominator, and you have to represent, so the common denominator for this is going to be x plus 1 and x minus 1. Kind of running out of room there. So the x minus 1 cancels out, and I'm left with negative 4x times an x plus 1 plus a 4 with the x plus 1 canceling out. I'm left with an x minus 1. And then the whole thing is gone, and I'm just left with a negative 8. Then you simplify. So when you distribute, I'm left with a negative 4x squared minus 4x plus 4x minus 4 equals a negative 8. A negative 4x and a positive 4x is 0. So you have a negative 4x squared minus 4 equals a negative 8. So, whenever you do this, I'm going to add 4 to both sides, because remember, there are several ways to solve a quadratic. Setting it equal to 0 is one, but when you just have a squared term and that's it, you can always use the square root property. So I have a negative 4x squared is equal to a negative 4, oops, my equal sign. Divide both sides by a negative 4, and x squared now equals 1. And when you square root, remember, anytime you physically make that square root symbol, you put that plus or minus in there. Cool. So there is my answer. Anybody see anything wrong with that? Wahaha, very good. Both of those answers I cannot have, a plus or a minus 1. Neither one are good answers because they make my denominator 0. So what is the actual answer to this problem? Yep, a great big no solution. Great job, guys. So this is our last example of the rationals. Remember, the key to rational equations is setting that denominator equal to 0, figuring out which values x cannot be, and then checking your answer. Cool.